Okay, the recording started for Rick's webinar today. We'll post that on our YouTube channel. Once that's up there, we'll send you out, everyone who even registered for the course will receive a link to that, to the recording, and also a link to a PDF of the slides will be shared with you. So with that, let's get started and turn things over to Rick.
Thank you, Bill, and welcome everyone. Good afternoon to you. Let's see, show my screen. And I am, can you see my screen now?
He came up on the red screen for the red calc.
Oh, it did. Okay. Okay, I'm going to back so you can see this screen over here moving around now.
Yep, see you moving that.
Is that right?
Mm-hmm.
Okay, I'm going to reboot here a little bit. Excuse me while I make a change.
There you go.
Okay, you should see things now. The title slide. And again, good afternoon. With the number of people we have on the call, I want to encourage you to ask questions as we go along. As Bill said, he will filter those and interrupt me whenever he feels appropriate, and he's very delicate about interrupting, so don't worry about that. And questions are good. They're, I hope, going to help you, and they will help others. And they help me because I get a sense of where you are with things and if you're with me or not. So please, as we go along, ask questions. What we are going to do, as you know, is discuss zone pressure diagnostics. I'm first going to go through an introduction of what it is and how it can help you out in your work. It's a fairly high level topic in the category of building science. I'm going to talk about non-modifiable zone analysis and the disadvantages of this method. Some of you, I imagine, have only used this type of zone pressure diagnostics. By the way, some of the terms you are going to hear me using, you might not have heard before. What I've tried to do is bring in some terms that I hope will help with your understanding. I've been teaching about zone pressure diagnostics for about 20 years now, and have done my best to try to make it more understandable. The third bullet is modifiable zone analysis. For this, you need a calculation aid, either a chart or an online tool. I am going to be using, as Bill mentioned, the Residential Energy Dynamics tool. That's my company, along with Charlie Holly. And the tool I'll be using is online and free for you to use. And that is mentioned in the last bullet. So we will go through at least one example as we go through the topics today. So first of all, an introduction of zone pressure diagnostics. For tools, you must have a blower door. A blower door is very important. It can be from the Energy Conservatory. It can also be from Retrotech or any other blower door. You need one or two digital manometers. It is best if you have two. It doesn't have to be the latest. I, for example, have an old Energy Conservatory DG3, and I also have a DG700. I often use the DG3 when I'm doing zone pressure diagnostics. Otherwise, I never use it. It can shortcut things a little bit and help you stay better organized out in the field when you're doing ZPD. You need manometer hoses. The best here is to get a set of hoses. I know that the Energy Conservatory sells these. Retrotech probably does also. A set of hoses of different colors that are 50 feet long. It's very helpful when you're doing ZPD out in the field. And you also need, if you're doing modifiable zone analysis, you need a calculation aid. By the way, all of these that are available that I know of are free of charge, so you shouldn't have to pay for any of this. And once again, as I said, we will be using the Residential Energy Dynamics ZPD tool, or the RED, short for Residential Energy Dynamics tool. So what's it all about? Well, with zone pressure diagnostics, we must identify pressure boundaries. You can see there are 4 pressure boundaries or air barriers that are called out on this slide. It's a simple house, a 1-story, and a basement. The attic is unconditioned. The most common zone pressure diagnostics test that's done is from the house where this guy is standing to the attic. Now, this is generally modifiable zone analysis because there's an attic hatch here. We can do a test with the attic hatch closed, and then we modify things. We open the attic hatch and do another test. And as a result of the new data we get from the modified condition, we are able to tell what the leakage is between the house and the attic through this pressure boundary. And we are able to tell what the leakage is from the zone, in this case the attic, to the outdoors through the pressure boundary made up by the roof and the gable ends. This diagram doesn't show gable ends, but just pretend that they are there. Notice that the blower door is running. It is depressurizing the house. It can also pressurize the house. You can do it either way, a depressurization test or a pressurization test. The basement, I live in the Northeast, the basement is usually considered part of the pressure envelope. And the basement ceiling can be assumed to be a pressure boundary. And if we do modifiable zone diagnostics to the basement, we can determine what the leakage is through the basement wall. That can be helpful. Of course, the outside walls of the house are also pressure boundaries. Sometimes you can see the term down here, series leakage. Sometimes ZPD is called series leakage because it is exactly analogous to a series circuit in electricity. In electricity, when you do wiring, there are parallel circuits and series circuits. In this case, if we go back to the diagram, there is resistance to airflow through this pressure boundary, and there is resistance to airflow through this pressure boundary. So resistance here, just like an in-series electrical circuit. So that's why it's sometimes called series leakage testing. These are the common zones and pressure boundaries for those zones in a typical house. Interior pressure boundaries in the center column and exterior pressure boundaries in the column to the right, and the zones. Now, the zone is a term we use for the general area that is bounded by pressure boundaries. And these are the specific zones: the attic, crawl space, basement, garage, and perhaps knee walls, although that is difficult to pull off correctly. Most commonly, the attic is used. For example, the low-income weatherizations in Wisconsin and Maine, and I think in Ohio, routinely do zone pressure diagnostics to attics as the zone, modifiable zone pressure diagnostics. Wisconsin and Maine also do ZPD tests to attached garages if the geometry of the garage is accommodating. Crawl spaces can be done, basements can be done, and as I already said, knee walls are not very often done, but it is a possibility. If we look at attics, you can see the interior pressure boundaries. This is a floor ceiling, the floor of the attic, and their bypass paths, exterior pressure boundaries for the attic, the roof, the gable ends, the soffits, and so on right down through the chart to give you some idea of what ZPD can handle out in the field. Now, what are the objectives of ZPD? Well, there are many. First of all, we can determine the leakage in CFM50 flow rate, just like you do with a blower door. You end up with a blower door value, CFM50 value, when you do a whole house blower door test. Well, we can determine the CFM50 flow, I'm going to go back here, through just this pressure boundary, for example. That can be very useful because if we know the CFM50 flow, if we divide that by 10, it gives us the approximate leakage in square inches. So we can do a ZPD test before and after air sealing and get a pretty good idea of how many square inches of bypasses we have plugged. That's pretty powerful. Going back to this now. So the first bullet, we can determine the leakage in CFM50 flow, and if we divide by 10, approximately the area from the building to the zone. We can determine the CFM50 flow and the area from the zone to the outdoors. Once again, I'm going to go back to that diagram. That is this in the case of using the attic as a zone. Now, some of you and some of your programs, whether they're low-income weatherization, a public program, or private home performance, you are concerned about the amount of venting in an attic. Well, Zone Pressure Diagnostics can give you the number of square inches in this pressure boundary, the roof and the gable ends, and any venting. And that can be very informative and useful, and it's probably the best idea you can get of the square inches of venting in an attic. Whoops, I went the wrong way. I'm sorry. The third bullet, determine the through zone CFM50 flow from the main house to the outdoors. Again, I'm going to go back. This is a little bit different. Now, in this case, we have this resistance of this pressure boundary and this one. So it's through both of these pressure boundaries, the flow through both. This is called the total path or the through zone leakage. This is a useful number, but it's not reliable to divide this number by 10 because we are going through two pressure boundaries rather than just one. The fourth bullet, to help appraise indoor air quality issues such as CO from attached garages or bad air from crawl spaces. Now, in some cases, there might be, because of mold, mildew, other things in a crawl space, we might very well want to know what the connection is from a crawl space to the living area. ZPD can help us with that also. Moving on with objectives, we can determine the effectiveness of air sealing pre and post weatherization. I mentioned that already when you're doing air sealing in an attic, for example, when you're doing air sealing of a basement wall or a sill area of a basement. Another important surface or building assembly is the common wall between an attached garage and a house. Very often that's the kitchen. How effective is that air sealing? ZPD can give us a very good idea of that. The next bullet, it makes air sealing targets possible. At the end of our time together today, I will show you what Maine and Wisconsin are doing for air sealing targets from the house to the attic and from the house to an attached garage. ZPD makes those targets possible. ZPD also demonstrates the downside of adding attic venting. You probably know that if you add too much attic venting, it can increase energy use in the house because it increases the whole house CFM 50, and you know that that's one of the big components of heat loss in the wintertime or heat gain in the summertime when the house is being cooled. So ZPD demonstrates that, and I'll point that out as we go along. Something I've never run into, but someone in one of my sessions recently on ZPD suggested that ZPD is really good for liability cases. He is a contractor, and he did some work on a house, and after his work was completed, the homeowner filed a lawsuit claiming that he had created moisture problems as a result of his air sealing and adding ventilation and other things that he did in the house. He did a very systematic approach with his work. He had fortunately done zone pressure diagnostics to a crawl space. He had his data, and he presented that data in a court case. The engineer representing the other side had no idea what was going on and had no data, was merely talking anecdotally, and the case was thrown out of court. So it helped out a great deal. Hopefully you won't have that happen to you. So there are many, many good uses for zone pressure diagnostics. It does take time, and it is not something to use on every house. I might as well mention that right now. It's a bit of a Goldilocks thing. If a house is really, really tight, let's say 800 CFM 50 for the whole house, it's probably a waste of time to do zone pressure diagnostics because you're most likely not going to do any air sealing anyway, so it won't help you out. If the house is really, really loose, let's say the house we're looking at on the screen now, and it is 3,400 CFM 50, it's probably too loose for you to find out anything useful from zone pressure diagnostics. It would be good to do some air sealing first and then do ZPD, and then you can find out something useful. So if a house is really tight, it's probably not useful. If it's really loose, it's probably not useful. And remember the Goldilocks thing. If it's in the middle somewhere, it's probably just right for zone pressure diagnostics and would be helpful. A guideline for a ZPD, and I'll read this: each pressure boundary imposes a resistance to airflow. Remember, I've already said it's just like electricity. I want you to think of an air barrier as a barrier of resistance. It's just like a light bulb in an electrical circuit. The greater its resistance to airflow, the higher the pressure difference across the boundary. Now, that pressure difference is created when the blower door is running. We have it in a typical, say, front door or back door in the house. We're running the blower door, and we use the digital manometer. And for example, if the attic is the zone, we put a hose up in the attic and then close the attic hatch again and look to see what the difference is across that pressure boundary. The greater the difference, of course, the maximum would be 50 pascals because that's usually what we're going to use for house pressurization or depressurization. The greatest is 50. The closer it is to 50, the greater the resistance to airflow. Now, if you look at this house, and by the way, this might look like a Cape Cod style house to some of you, but the upstairs, the attic, is not conditioned. This is an unconditioned attic. And let's say the blower door is operating and we're depressurizing the house to a level of 50 pascals, typical. And we use our digital manometer and we measure the pressure difference from the house where this guy is standing to the attic, and we get 37. And then we measure the difference from the attic or the zone to the outdoors. We get 13. Notice that 37 and 13 add up to 50. It's always going to be that way, plus or minus a couple of pascals. If they don't add up to 50 and the house is at pressurized or depressurized to a level of 50, something's wrong. Maybe somebody's stepping on the hose, or the hose is totally crimped or something. Now think about which of these pressure boundaries has the greater resistance to airflow. Somebody answer that question, say it aloud, and maybe I'll hear it. But this one, the one with the able to hold the greater pressure difference, has the greatest resistance to airflow. And of course, that's exactly what we want. We want this pressure boundary to be much tighter than the roof and the gable ends. Now, while this is on the screen, I want to tell you a story about a weatherization program in mid-Atlantic states, but that's the most incriminating, albeit I won't tell you which state. They had written into their weatherization standards that if they got to the house and they did a pressure measurement from the house to the attic, and they found that this number was 45 or greater, their standard said there was no reason to do any air sealing of this air barrier. Well, as it turned out, some savvy weatherization folks in that state would go to the house, and let's say this is 43, so they have to do some air sealing because it's not up to 45. Also on the work order would be adding attic venting. If they add attic venting, what would happen to this number, the pressure difference from the zone or the attic to the outdoors? Adding attic venting is intentionally putting leaks in this pressure boundary, so it's making it less resistant to airflow. Now, there's nothing wrong with putting venting in as long as you don't put too much in. If this number goes down because it's made leakier, this number goes up. Remember, they always add up to 50. So some people caught on to this and they were playing the system, and they eventually changed their standards. That's an example of non-modifiable zone pressure diagnostics, and that can be misleading. I hope you understand that, what I just said. This is the Residential Energy Dynamics, or the RED tool. We're going to look at this in a larger size. This is just so I could get it on the entire screen. This is the ZPD Tool, and the website is www.residentialenergydynamics.com. I'm going to briefly show you the sections of the tool and go down through so you have an initial sense of where we're going with all of this. The top section of the tool has identification, and you may choose whether the blower door test is depressurization or pressurization. When I have the live tool on screen, I'll show you what the advanced inputs are. Now, some of the terminology here is new with the tool. We really spent a lot of time on this. We got some other people that really know a lot about ZPD to help us out. Anthony Cox from Virginia, Colin Olson from the Energy Conservatory were very helpful to us in putting this tool together. This next section is the initial zone configuration. This is when you arrive at the house or after you do some initial air sealing at the house to bring it down to the just right level of tightness so that zone pressure diagnostics will be useful. So in here you put blower door pressures, and here we have house with reference to zone pressure. Again, I'll show you how this works when we look at the live tool. WRT, perhaps you can see that on your screen, stands for with reference to. Notice right here, there is a blower door flow adjusted to 50 pascals. That's a whole house blower door test. So this is the initial zone configuration. Then we modify the zone and we look at the pressures again, and we do a whole house blower door test again with the zone modified. So we're merely changing the zone so that we can determine the characteristics of the leakage in the initial zone. The results then are down here at the bottom. With any of the RED tools, font that is in black indicates an input, and font that is in blue indicates a result. So these are the final results. Zone to the house, leakage at 50 pascals. This is the leakage area of the zone to house. This is an attic, so this is attic to house. Attic to outdoors, right here, this is the CFM 50 leakage. This is the square inches. That tells you how much free vent area there is from the attic to the outdoors. And this is the through zone or the total path. And I will explain all of those as we go through the topics. So non-modifiable zone analysis. This does have some usefulness, but modifiable zone analysis is much more useful, and you get some really good info from it. You do not need a calculation aid for non-modifiable zone analysis because all you're doing is looking at pressure differences. You're not modifying anything, usually because the zone is not capable of being modified. So it allows the analyst, that's you, to determine if a space is connected by airflow or pressure. So this can be useful, but you should use it with caution. Examples of where you might want to use non-modifiable zone analysis: crawl space, soffit above kitchen cabinets. You might want to know if that's connected to the attic or not. It often is. An attached porch roof ceiling cavity. I'll show you an example of that, although we won't go into too many specifics with it. Joist cavities in a Cape Cod style house is another example. Now, something I want you to keep in mind with non-modifiable zone analysis, it's really important, is all we're finding out with these relative pressures is the relative leakage between one pressure boundary, say the roof, gable ends, and the attic floor. Now, this is a contrived pretend situation. But what I've done here is I put 2 leaks in the attic floor. Let's assume those are the only leaks in the attic floor. I put 4 leaks of the same size in the pressure boundary made up of the roof and the gable end. So we have, let's say each of these is a square foot. We have 4 square feet here in this pressure boundary and 2 square feet here. With that being the case, we would get these pressures: 37 from the house to the zone and 13 from the zone to the outdoors. This indicates that the leakage here is twice what the leakage here is in this pressure boundary. So, in other words, the resistance through this upper pressure boundary is only half as great as the resistance here. Or another way of saying that, the resistance through the attic floor is twice what it is through the roof gable ends. Now notice what happens on the next slide. The pressures remain the same, 37 and 13, but now look at the size of the holes. We still have only half the leakage in the attic floor as we have in the roof and gable ends, but the pressures are the same. So if we do non-modifiable zone analysis where we are only looking at pressures and we're not modifying anything, all it is telling us is the relative leakage between the two pressure boundaries. It's really not telling us any more than that. This is a chart that gives you some idea of the relative size of the leaks for different pressure differences. All of these, the 12 and the 38 and the 25 and the 25, they all add up to 50. 25 and 25 indicates that the two pressure boundaries are of equal leakage or equal resistance. This one is highlighted because it's what we had on the on the previous slide, 13 and 37. Some people find this useful, some don't, but this is the one we're looking at. The RED tool gives you this ratio. It reports this ratio. So in this case, the roof with these pressure differences, the roof is 4 times leakier than the ceiling. So this pressure boundary where we have a 5 is 4 times leakier than the 45 that we have here. If I go back to the table, 5 and 45 is right here, and you can see one is 4 times leakier than the other. A place in the field where I have often used non-modifiable zone analysis is a porch like this. Let's say this is a balloon framed house with open studs and an open second floor cavity. Is that open second floor cavity connected to the cavity that makes up this porch roof, the roof and the ceiling below, which you can't see? Well, if you do a blower door test on the house and you stand out here on the porch and you, with your digital manometer, you stick a hose, drill a hole and stick a hose up in the ceiling, you can tell if the pressure in the house, the 50 pascals in the house, is having an impact on the pressure in this roof ceiling cavity. If you can tell if there's a pressure there, but pressure between the cabin and the outdoors, but you can't tell how leaky it is. But it does give you an idea of whether it's connected or not. And if it is connected and you feel it's a serious connection, then it might be worthwhile to get in there and fix it. Maybe some of you who are with us today have done this before. I've done it a few times out in the field. My preference, if the shingles are okay, is to take shingles off, save them if possible, then go in from above, fix it, and then patch it back up again with the same shingles. So this is a place where non-modifiable zone pressure diagnostics can be useful. Again, all you need for that is a blower door and a digital manometer. You don't need a calculation aid. I've already said that there can be misuses of non-modifiable zone analysis. I mentioned the weatherization program in the Mid-Atlantic state. So now modifiable zone analysis, this is much more powerful. We're going to do an example. For this, you need a calculation aid, a tool. And with this, you actually modify, hopefully in a non-destructive way, you modify the zone. Again, take pressure differences, again, do a whole house blower door test, put the data in your calculation aid and find out the characteristics of the individual pressure boundaries of the initial zone. So the basic test is, just to go through this quickly, we take the pressure differences while the blower door is running of the initial zone. We modify openings in one of the pressure boundaries. It's best to modify the tightest of the two pressure boundaries if that's possible. Then we get the answers. We get the CFM50 flow from the house to the zone to the outdoors, and the through zone. And then we can determine square inches in the house to the zone and the zone to the outdoors. So this can be a very important quality control test for people out in the field. If you want to know how well, for example, an attic was sealed, you can do zone pressure diagnostics. So in the past, there's been an add a hole method and an open a door method. With the RED tool, those are combined. The RED tool is very easy to use, but it's very powerful and quite accurate. This is a tool that has been around for quite some time. This was put together by Anthony Cox and Colin Olson. I've always liked it because of the colors. The colors have to do with uncertainty. We'll talk about uncertainty a bit with the RED tool as we get there. So this is usually a laminated chart. Then there's one side that's a hole added from the house to the zone, and you flip it over, it's a hole added from the zone to the outdoors. This is for adding a hole. This one is for opening a door. This is often used from the house to an attached garage. And again, there are two sides to this. One is for the opening a door from the garage to the house, and the other side is opening the door from the garage to the outdoors. So some of you probably use these charts, and that's just fine. You can continue to use them if they suit your needs. Examples of modifiable zones, the big ones, these are probably in order of the way you might use them in the field, the most common ways. Attics are number one, then attached garages if the geometry of the garage and the house accommodate that, basements, and then crawl spaces. A little aside, a few comments about digital manometers. As I've already said, you've got to have a good one. You've got to have a good one. This is DG700 from the Energy Conservatory. They now have the DG1000 that's out and apparently selling very well. This is still a perfectly fine manometer, DG700. When I learned about zone pressure diagnostics, the most difficult thing for me to learn was how to hook the hoses up and where to put them. And for me, it's really important to have with reference to. You notice how I've written that here, with reference to. So whatever you hook up to this pressure tap with reference to wherever this pressure tap is. And we'll look at that in an example coming up. This is the Retrotech DM32, really nice digital manometer, a little bit different than the Energy Conservatory one, but it does all the same things. So here's a simple diagram with a DG700. The house is being depressurized to a level of 50 pascals, and we have that reading right here. So we have the house, the open tap, with reference to a hose that's to the outdoors. And on the other side of the manometer, a separate channel, we have the house with reference to the zone, in this case the attic, and that gives us 32. That's also written right here. Now, if the house is depressurized to 50 pascals and this is 32, then this has to be 18. Well, how can we check that without moving? We can just move the blue hose on the manometer like this. So if we move that hose, now we have the zone with reference to the outdoors, and that is 18. So as I said a minute ago, this is what I really had trouble with when I was learning about ZPD. So let's do an example using the RED tool, and we'll do an example to an attic. Bill, before I start this, are there any questions?
Rick, so far I've only got one question, and it was more of like a preference kind of thing. Do you want to hear it?
Yes, let's hear it. Let's take it,
Okay.
then I'll start this.
We have been using mastic for sealing sill plates to block walls. Others use clear caulk. Which do you feel is better?
Mastic for sill plates, like the mastic that's used on ductwork,
I believe
I
so,
assume.
yes.
I think that a lot of that has to do with aesthetics. I think they both do a fine job with the character of the leakage in sills. I think that a caulking tube can do a neater job. Caulking can also be clear, as the questioner brings out. As far as, so I think I think I could be faster with a caulking gun with silicone or some other good caulking compound
Mhm.
than I would able to be with mastic, and I think I could do a neater job. And I think as far as durability, they're probably about equal.
Very good.
Okay.
Good.
So I'm gonna. This is what we got for the example. So try to get this into your head. What we've got for the initial zone configuration. Initial zone configuration is right here. The blower door is depressurizing from the house to the zone. The zone is the attic, is -32. It shows right here on the manometer, and it shows right here. And therefore, the zone to the outdoors is 18, and the whole house blower door number with the attic hatch closed for the initial zone configuration is 2400. Then what we're going to do is modify the zone by, I should have changed this, but just take that darn attic hatch and lay it aside. Either put it on the ground here or put it aside in the attic. There is no need with the RED tool to partially open it. Just get it out of the way. Let's assume we're doing that. I meant to change the diagram. This shows that it's partially open. We used to have to do that with older methods to get things just right, but now we don't have to do that. So just get it out of the way. With the attic hatch all the way open, now it makes this pressure boundary less resistant. So this goes down, and this goes up. Oh, and this, the whole house CFM 50 goes up to 2950. So what I'm going to do now is go to the live. Bill, can you see the RED tool now?
That looks good.
Okay. This is the live RED tool. We'll go through that example. I hope you can remember it. If I put both on the screen at the same time, it will be very small. So let's just try to remember that. And the tool is already filled in for the values of the example. So what I'm putting up here is the Jones attic, and I have a choice of pressurization or depressurization. Now notice what happens if I choose pressurization. I put negative values down here for my blower door. If I choose pressurization, the tool is going to catch these negative values as an error, and it's going to stop you. It will not let you continue when you see a stop sign. So the question, the drop-down asking for pressurization or depressurization is to help with error checking for you. With all of the RED tools, notice what happens if you can see my mouse pointer. When I go over one of the labels, a question mark shows up. If I click on that, there's a drop-down help dialog box. If you're using a smartphone or a tablet with the RED tool, you just touch the label and the same thing happens, and you get rid of it by Xing it out. So if you have a question of, gee, what does this mean or what does that mean, just go ahead and click or touch in the appropriate spot. So this is the initial zone configuration. The house with reference to the outdoors. There's no choice here. There's no drop down. BD off means blower door off. In other words, the baseline. The baseline. Now, if you click on that, it'll tell you what that's all about. But if you're using the auto baseline, or if the baseline is 0, you put 0 in here. Let's assume I'm using the auto baseline on my digital manometer. So that is 0. The blower door on value is 50. The difference in pressure between BD off and BD on is 50. It does the subtraction for you right there. Now, when I go to the next one, what is the house with reference to zone pressure or the zone with reference to outdoor pressure? I'm using the house with reference to zone pressure. What is the baseline? Well, I'm going to use the auto baseline again. So this is 0 and -32. Because I'm depressurizing, I must put a negative sign here. The subtraction is done automatically, and we've got -32. We also, in this initial zone configuration, we do a blower door test, and the CFM 50 is 2400. You might remember a table I showed you where I said that though the values, the ratios, the leakage ratios were reported by the RED tool, that's right here for these numbers. Now, so this is initial. Just in passing quickly, I want to show you the advanced inputs in case you want to use it. By the way, there is a user guide that you get to by clicking on the blue circle up in the upper right of the tool, and it explains all of this. House temperature, well, as you know that if the density of the air changes, the blower door number changes. So that's what this is for. If you have really cold temperatures, really warm temperatures, you might want to adjust the temperatures. And that will adjust the blower door numbers. There's some other things here I really don't have time to go into, but these can help you with accuracy. I will mention this one, baseline pressures with reference to outdoors at 5-second intervals. This is not setting your DG 700 to 5-second intervals. This is actually taking a baseline every 5 seconds. And if you look at this, you can see that we have -1 for this example, -1, -2, and 2. This is an indication that it's windy outside. Now, if we had -1, -1, -1, it would be very calm outside. But this tells us that it's windy, and that data is taken and used. I haven't mentioned it yet. It's used in the uncertainty values down here in the results. So that's kind of more advanced, but if I uncheck used advanced inputs, even though all of these numbers still are here, they are not used in the calculation if I uncheck that. So those are still there, but they're not used in the calculation. So back to the initial zone configuration right here, which I've already filled in. Now we're going to open the attic hatch, and with that modified configuration, this is the modified zone configuration. With that, I'm going to have to increase the RPM of the blower door, right? Because I've just made the attic floor pressure boundary leakier. So To get to 50, I've got to increase the RPM of the blower door. I'm assuming I'm using the auto baseline. House with reference to zone, auto baseline. Now that goes from 32, because it was a better pressure boundary, now to -15, because we've opened a big hole in it. And we also, with that hole open, do another whole house blower door test and report the at 50 Pascal value, and we have 2950. Now, if you've done ZPD before, you might have noticed already there's no need to have a tape measure for this tool. That's been taken out of it. You don't have to measure anything. You don't have to measure a hole or a door, but you do have to do a whole house CFM 50. That's much more reliable than measuring, and probably easier because the blower door is set up already. So we've modified the zone and we've entered that data here. Now we have the results. We have what we have found out about the initial zone configuration. By this modification, we have found these characteristics for the initial zone configuration. So the house to zone leakage is 1400 house to zone, or I mean, sorry, the zone to the house or house to zone, same thing. In this case, the zone is the attic, is 1400 CFM. By the way, you can change the units if you wish. CFM is what you're accustomed to. And this is the uncertainty. 1400 plus or minus 600. That's a lot of uncertainty. Well, guess what? There has always been significant uncertainty with zone pressure diagnostics. We decided with the RED tool to report that. With all of the RED tools, all of the other ones, you can turn the uncertainty reporting on and off. You cannot with this. It's always on. But this is the important number for this example. This is the uncertainty. And the reason we put this here is so that you, while you're out in the field, can come up with methods for reducing the uncertainty or increasing your accuracy. By the way, this 44% is what this is right here. This is expressed as an absolute number. This is expressed as a percentage. So 1400 CFM 50, we divide that by 10 approximately. Here it is an exact division by 10. 144 square inches plus or minus 64. That's from the house to the attic. From the attic to the outdoors, 200. We expect that because it's not as resistant an air barrier, plus or minus 650. And here we have the square inches of leakage from the attic to the outdoors. This is essentially the attic venting area. Here is our uncertainty. And this is the through zone, which is 1000. This value will always be less than the two above it, because this is including both pressure boundaries, both points of resistance. And finally, this value tells us that 42% of the leakage in this house is going through the upper part of the house, through the attic floor and the roof and gable ends. By the way, if we put more venting in, what happens to this number? We make this pressure boundary looser. The 2000 will go up, this will go up, and this will go up. This is the one that has a direct impact on the whole house CFM 50. This one will stay the same if we put attic venting in. So that is an example using the RED tool an example to the attic. Bill, any questions regarding that or anything else?
No, I'm really not seeing anybody. Someone asked for the website address for the RED tool, and I provided that to the whole group.
Okay, thank you.
Welcome.
I'm going to go back to the slides now. And I'm going to explain all of the slides I just went over by using this slide. This reports the CFM50 values that you just saw in the RED tool. The whole house CFM50 is 2400, and these are the pressure boundary values. So I want to explain this a bit. We found that we have a flow rate of 1400 CFM50, or about 140 square inches of leakage right here. What that means is that if we took a chainsaw and cut the roof and gable ends off and took a crane and put that whole structure in the backyard, we would have 1400 CFM50 of leakage through this pressure boundary by itself without the roof, excuse me, without the roof. On the other hand, what does the 2000 mean through the roof gable ends? Well, if we tore this ceiling down completely so that there were no pressure boundary characteristics of this ceiling, the flow through the roof and gable ends would be 2000 CFM50. Of course, again, that's kind of a pretend situation, but the wonderful thing is if we segregate it in that manner, we can get a pre and post CFM50 value through here, the more important of the two pressure boundaries. And if we divide those by 10, we can get a pre and post square inches of leakage, pre and post air sealing square inches of leakage through this pressure boundary. That's really powerful. The 1000 through zone or total path is the leakage or the flow through both of the pressure boundaries, the attic floor and the roof and gable ends. As I've already said, this will always be less than either of these two because this includes only this pressure boundary. The 2000 includes only this pressure boundary, but the 1000 includes this pressure boundary and this pressure boundary. So you can find out some very powerful things with zone pressure diagnostics. So a few things about the RED ZPD tool. You don't have to measure, as I've said. You may open or close more than one opening. Now, I'm going to go back to that. I went over that quickly. I didn't go over it at all. The hole, here's the modified zone. The hole or the door, it doesn't make any difference which one, located between the zone and the house or the zone and the outdoors. So you can choose, and you must choose correctly where you are modifying, where you're opening a door or opening a hole. But you can also, with the RED tool, you can add a hole or open a door, or you can plug a hole or close a door. I've done that only once out in the field when the attic had just too much venting in it, and it was better to close off venting than do anything else. So that's unique about the RED tool. You can also, you don't have to worry about how many holes you're opening. Usually you're going to open a hole or open a door. I have been in houses that have 2 attic hatches. Well, you'll find if you use this tool that you will reduce the uncertainty value or increase the accuracy if the bigger the pressure shift from initial zone to modified zone. So if we opened another attic hatch, if there were one, this value would go down because we would make the attic floor even leakier. So we'd have a greater difference between the 32 and the 15. We'd have a 32 and a 10, for example, which means the accuracy here would go up. So this uncertainty number would go down. So we are reporting uncertainty so you learn out in the field when you're using this tool what you can do to make your results more accurate. It's important to enter the signs that are necessary, and if you don't do that right, it's going to check you and give you an error message. There is a user guide for the RED tool, and I recommend that you use that. And I've already mentioned the pop-up help. If you click on the label or touch the label, it will explain what that label is about. It will also give you input ranges. Now, one other example I'll go through with the time we have left. I think I can get through that. It's an attached garage, and I'm just going to write this down so I've got it. We start with 2250 and 32, and it goes to, let's see, the house to zone, 3218. So that's the initial configuration. And then we go up to 3000. So you'll see how this works a little bit differently when we open the door. I'm going to go back, open the door as compared with, I'm going to change this to garage. It's depressurization, and I'm going to leave these initial pressures the same, except the whole house CFM 50 is now 2250. So to describe this, we have an attached garage. It's not a tuck under garage. It's attached, and the garage rafter area is distinctly separated from the house rafter area. And the garage door, overhead doors or door is pulled down and closed, and any door that's a swinging door is closed. So we measure we start with our starting pressure, and these are baselines. House with reference to the zone. The zone is now the garage. That's a -32. And with the garage closed up and the door from the house to the garage closed, the whole house CFM 50 is 2250. Then we modify the zone. Now, when we modify the zone, we are opening the door totally from the house to the attached garage, and that's a big opening. And I'm going to say that's going to take us down to 0. So there'll be no pressure difference between the house and the garage with that door open. And the whole house CFM 50, according to the example, now goes up to 3000. Now again, we are not measuring the size of the door. We're adding we're adding a hole or opening a door, and the hole or the door that we're dealing with is between the zone and the house. The zone in this case is the garage, so we've made our drop-down choices correctly up here. And here are our results. Now, the important value here, just like with the attic, is the pressure boundary from the zone, in this case the garage, to the house. That's now got 110 square inches of leakage in it. We've got a pretty good accuracy here. And the reason the accuracy is better than the last example is we have a greater pressure shift. We have a pressure shift from -32 to 0. That's 32 pascals. I think the last one was 17. in the attic example. So because we have a greater pressure shift from initial to modified, we have a greater accuracy. Now, this would not meet the Wisconsin target, nor I think would it meet the Maine target. We'll look at those in just a moment. So that's another example using the garage as a zone. Now I'm going to go back to the slides. That's what we just looked at. It's a little bit about uncertainty. Now, as I said, at the end of our time together, I was going to tell you what I know about some states that have targets that they're using with zone pressure diagnostics. First of all, Wisconsin. Wisconsin's got a good weatherization program. As far as I know, they were the first to start using targets for zone pressure diagnostics. And their target, the through zone leakage to the attic. This is a target to the attic. It's not a requirement, it's a target. This is something that they're folks in the field that are doing the air sealing, whether it's a contractor or a crew. This is something they are trying to comply with, although if they don't, they don't get marked down for it. As far as I know, they are able to meet this target about 50% of the time. So their target is the through zone leakage to the attic should be 10% or less of the whole house leakage. Now I'm going to quickly go back to the RED tool. This is the through zone value. The whole house leakage value in, well, this is the garage, so this doesn't really work. I'm sorry, I was going to try to show it here, but I'll just show you the position of the numbers. The 800, their target is, let's make that number 10% or less of this number. You can see in this case it doesn't make it. It's a real challenge. Well, let me go back to that again. This is a real challenge because as they bring this down by air sealing the attic, by air sealing this pressure boundary, their target's based on this number. This number comes down. So what they've got here with this target is a moving target. So for example, if the whole house leakage is 2200 CFM50, the attic through zone leakage should be less than 220 CFM50, or in this case, this would have to be 220 or less.
Hey, Rick.
Yes, Bill.
We have one comment here from Jonathan. The Montana WAP has a required ZPD of minus 45 for attics, and they intend to implement series leakage zone testing.
Yeah, thank you for that comment. Did you say Jonathan, Bill? That was from Jonathan? Yes, thank you, Jonathan. That is similar to the one I talked about in the Mid-Atlantic. It's a non-modifiable zone target. In my opinion, it's faulty, and they should do something more like Wisconsin has done, or one like Maine, which I think is simpler. I'm going to show you that next. This is the main target for attics. The house to zone CFM50 should be 30% or less than the attic square footage. Now this is based on different things. In other words, if the square footage of the attic is 1,000, the zone to house CFM50 should be 300 or less. 30% of the square footage or less. That's not how the Wisconsin one is, but it gives you an idea of how these targets can be formulated. By the way, isn't this a beautiful attic? Don't you wish every house you went into to weatherize had a nice clean attic like this one? Now next, attached garages. The Wisconsin low-income weatherization target is 50 CFM 50 between the house and the garage. So the common wall between the house and the garage. Now if you take 50 CFM and divide it by 10, what does that give you? 50 divided by 10 is 5 square inches. That's extremely tight. But think about what can happen. What can happen in the garage? Well, the car can be started and warmed up. When a car is being started and warmed up, it gives off tremendous amounts of carbon monoxide. Or there can be gasoline stored in the garage, or other VOCs, other harmful things. So that pressure boundary between an attached garage and a house is extremely important. This is what Wisconsin has come up with. Again, it's a target. It's not a requirement. They do their best to reach the target, but no penalty for them if they don't. This is what is done in Maine. This is quite a bit higher. For Maine low-income weatherization, the target between the house and the attached garage is 200 CFM 50, or approximately 20 square inches. So that's quite a bit. That's a magnitude of 4, looser than the Wisconsin one, but it's a target and it's a good thing to try to shoot for. You should try to do the best that you can with these targets. So Bill, that brings me to an end of my prepared comments and slides. I'm open to any questions.
I haven't seen any other questions come through besides the ones I mentioned.
Okay.
So if there are no further questions, I think we'll just wrap it up here.
Okay. Well, thank you everyone for your attention. I hope you have found this helpful. And if you have questions or comments about the RED tool or suggestions for improvement, please get in touch with me and I'll do my best to help or improve it in any way that you feel is reasonable. And Bill, I'll let you take us out and wrap it up.
Thank you, Rick. So we'd like to thank you for attending today. We will get the BPI-CEU information uploaded within 72 hours. And within about the same time frame, we'll be sending out a recording of this webinar, as well as a PDF of the slides which Rick wishes to share. It'll come out via an email to you from our constant contact system, and everyone who signed up will get a copy of those two items, a link and a copy of these slides. So I want to thank you for attending. Any of the tools you need to do any kind of this testing work, we carry True Tech Tools. Please give us a call, and we hope to continue to provide more information like this in future webinars, and I'm sure we'll have Rick back here within a couple months doing some other topics. He'll get real creative and come up with a couple things we'll be sharing with you. Thank you, everyone, and have a nice Memorial Day weekend. Take care.